is the deviation. So what we do is we try to, and remember one thing, never ever go for a correlation unless and until the number of input values of x is more than 5. That is, you need 5 data points at least. At least that is the minimum, because at times you must have seen in certain places or certain papers or something like that, people just plot a graph using just 3 data points, and you find, oh, our R square value is something like 0.99. Suppose if you have 2 points, what should be the R square value? Huh? It will be 1.
Yes.
It will be 1. Okay. Now let us say if I plot a point somewhere here. So now what you need to do is you need to plot a best fit line, not covering all the points, not necessarily, but still there is a little deviation. Very little deviation. So probably the R square value would be something like 0.9899, but this is a wrong way of doing or performing statistical analysis. Yesterday we calculated Wiener index, right? Like suppose for say CH4 it was 0, C2 at 6 it is 1, C3 H8 it would be 4, 1, 2, 3, 4, okay. 0, 1, 2, 1, 0, 1, 4. Okay. And now let us say we plot with the number of carbon atoms. So it's easy. 1, 2, 3. So 1, 2, 3. Okay. So you are plotting it like here. Then say 1, 2, 3, and 4. Say this is 4. So this is 1 point. Second two goes here, and the third somewhere here. And now you try to plot a graph. Okay. Very good graph. But that's not the way it should be. Here, the number of carbon atoms, and this is or the other way around, you can do it. Normally what we do is, here you have to have the independent variable, like say mean, or say now you are plotting a boiling point again. So 0 is this, okay, so let us say boiling point is minus, okay, let it be 20, 35, say it's a hypothetical, not exact, 45. Now you are trying to plot a graph of this. The graph will look very good. Let us, I'm going to put it like, say 10, 20, 30, 40, and say 50. So when it was 0, you're putting it here. When it is 1, the value comes somewhere here, and with the 4, it comes somewhere here. And now you have to plot a line of best fit. Okay, so I'm trying to plot a line of best fit. Looking good, probably 0.9, something like that. But now I go for C4H10, 1, 2, 3. It will be 10. C5H12. What it would be? Okay. 1, 4, and now you try to plot it like this. Then what you will find, say 70, 90. And now you will find like somewhere this or this. Now you try to plot this line. Now you see that the previously calculated or R square value, it was something like 0.95 something, approximately. Is it going to be the same now? No, it has deviated. Now you can see this deviation. This, like various points. The standard way of doing QSAR or QSPR is that the descriptor to property or activity or toxicity ratio, number of compounds, it has to be at least 1 to 5. If that is not so, then your all this theoretical assumption would go wrong. Now, how we do QSAR? Okay, this is one. Okay, now you know that yesterday what we calculated was the Wiener index, and that was a connectivity index. It was showing the distances between various atoms. Like here we call this as a vertex, and this is an edge. So for us, we are not bothered about the atoms. We are bothered about how we are representing them as points. So theoretically, this is C3H8, right? But what we have done is we have converted it into a graph. It's because this QSAR thing started with graph theoretical index. This is a vertex, say V1, V2, and V3. Yesterday you calculated V1, V2, V3. This Wiener index for this particular, say, particular molecule, it would be something like 0, 1, 2, 2, 1, 0, 1, 1, 0, 1, and 2, 1, 0. This is okay. This is a distance-based index. There are other indices which are of different nature. There is another index, what is called as Randage index, which is based on the connectivity. Like how many number of atoms are connected to this on the right side, and how many number of atoms are connected to it on the left side. And there are certain formula for this Randage index. So one what we did is a distance based, another is, say, connectivity based. Similarly, you can design your own index or use available indices. There are n number of indices, 2D indices, 3D indices, and I think I have put some of them. No. Okay, that will come in. When you correlate one index with one property, we can perform linear regression. Now it is we call this as a univariate correlation. But suppose if you have got more than one indices, like x, say x1, x2, x3. So what we do is we plot it like y is equal to m1 x1 plus m2 x2 plus m3 x3 plus this. This is a cumulative way of performing linear regression, wherein we don't call, in the linear regression we call this as a slope, but here this is called as an impact factor. Previously people used to call it something different, but we have coined this terminology as impact factor, and we have published it in I think Agassi Advances or something. This tells you how much is the impact of that particular index on y. So let us say we are correlating the boiling points of alkanes with various indices. So let us say let us say index 1, x1 is something, whatever name, whatever number. Suppose it is 10.3 x1 plus 3.2 x2 minus 11.3 x3 plus. So what information do you get from this? What is the coefficient of this 10.3, plus or minus? Plus. Here
Plus.
and here. Now, what does this mean?